Imagine for a moment that you could travel faster than a commercial airplane without ever leaving the ground. Imagine an entire city that thinks, breathes, and adapts to you like a living organism. Imagine a structure so colossal it could swallow 20 skyscrapers inside it. Sounds like science fiction, right? It isn't. At this very moment, engineers from around the world are turning these visions into concrete, steel, and reality. Today we're diving into 7 projects that challenge everything we thought we knew about the limits of human construction. These are works that don't appear in any textbook because they are writing the rules as they are being built. Get ready. What you're about to see will change the way you understand what is possible. And if this kind of content fascinates you as much as it does us, join this community. Just hit the subscribe button and turn on the notification bell. Before we continue, leave us a question in the comments. Would you live in a city completely controlled by artificial intelligence? We want to know what you think. Now, let's start with something that looks like magic but is actually physics pushed to its absolute limit. For more than half a century, Japanese bullet trains have been synonymous with speed and precision. Those white projectiles slicing through the archipelago became a global symbol of Japanese engineering. But even legends have a ceiling. The problem is simple. As long as a wheel touches a rail, friction rules everything. No matter how powerful the engine is, no matter how aerodynamic the design becomes, there is an invisible barrier that no conventional train can cross efficiently. We're talking about 500 kilometers per hour. So what do you do when the ground itself becomes your enemy? You stop touching it. Deep within the Japanese Alps, a new generation of transportation is taking shape. A train that doesn't roll. It floats. Literally. Using superconducting magnets cooled to temperatures near absolute zero, this machine levitates 10 centimeters above its guideway and moves without friction. The vehicle touches nothing. Nothing slows it down except the air. But building something like this isn't as simple as installing powerful magnets. We're talking about special alloys of niobium and titanium, submerged in liquid helium at minus 269 degrees Celsius. Colder than outer space itself. And all of this has to function flawlessly while crossing one of the most seismically active regions on Earth. 90% of the route between the country's 2 largest metropolitan areas runs underground. That means drilling hundreds of kilometers through solid mountains, navigating geological faults, resisting extreme hydrostatic pressure, and maintaining a trajectory so precise it allows operational speeds above 500 kilometers per hour. The investment exceeds $64 billion. This is not just a train. It's a declaration of war against the laws of physics. And the impact goes far beyond transportation. Once this project is completed, travel time between 2 urban giants will drop from 90 minutes to just 40. 50 million people functioning as a single economic unit. Geographical distance, humanity's oldest obstacle, will simply stop mattering. But Japan doesn't stop there. Because what's the point of a revolutionary train if the cities it connects are still stuck in the past? At the base of the country's most sacred mountain, something extraordinary is emerging. A city built from the ground up, but not like the ones we know. This is not a random collection of buildings growing chaotically over decades. It is an urban operating system. A living organism where every street, every building, every sensor is designed to work in perfect harmony. The streets here are not just strips of asphalt. They intertwine into a 3-level structure, completely separated. One lane exclusively for autonomous vehicles that will never experience traffic jams. Another for light personal mobility. And a third dedicated entirely to pedestrians, surrounded by vegetation that purifies the air in real time. But the real revolution lies underground. A 4th network that no one sees, where autonomous robots manage the city's entire logistics system. From package delivery to waste collection. Humans walk above, enjoying clean streets. Machines work below, invisible and tireless. The architecture uses wood produced with ancient techniques, but assembled by robots with millimeter-level precision. Energy comes from hydrogen fuel cells, completely eliminating dependence on fossil fuels. Every home is connected to a sensor network that monitors everything from air quality to the health status of its residents. And here's the most important part. This city isn't just a place to live. It's a full-scale laboratory. Every technology tested here, from assistance systems for the elderly to fully autonomous vehicles, can be perfected in a controlled environment before being exported to the rest of the world. It's the future rehearsing in private, before stepping onto the global stage. Now let's cross continents. Because in the deserts of Arabia, another colossal vision is taking shape. When we think of skyscrapers, we imagine slender towers piercing the clouds. Structures that rise vertically, defying gravity with elegant lines. But what if, instead of a needle, you built a cube? A perfect cube. 400 meters high. 400 meters wide. 400 meters deep. A volume so monstrous it could contain 20 times the most iconic skyscraper in New York. From the outside, it's a massive block projecting absolute power. But the real madness is inside. Engineers are not designing a conventional building. They are creating a space where physical reality merges with the virtual world. The interior walls will function as gigantic augmented reality screens and holographic systems. The environment can change according to the will of those inside. Today you could be standing in a tropical rainforest. Tomorrow on the surface of Mars. The structural challenge is terrifying. Supporting that weight requires load transfer systems never attempted before. Ultra-high-strength steels. Climate control systems capable of managing desert temperatures inside such an immense volume. Every engineering decision is writing a new chapter in construction history. This project is not a whim. It is the centerpiece of a complete economic transformation. A country that depended for decades on what it pulled from the ground is now betting its future on tourism, technology, and entertainment. The cube is the symbol of that transition. A monument to the ambition of reinventing itself before it's too late. But if we're talking about ambition, there's a project in Europe that makes everything else look modest. There is a question that has obsessed scientists for nearly a century. Can we replicate the process that powers the stars here on Earth? The sun generates its energy by fusing hydrogen atoms at unimaginable temperatures. If we could control that process, we would gain access to a virtually infinite source of clean, safe energy. The problem is this. We are talking about containing a gas at 150 million degrees, 10 times hotter than the core of the sun. No known material can survive that. Anything that touches this plasma would instantly vaporize. So the solution is simple. You don't touch it. In southern France, 35 nations have joined forces to build the most complex machine ever designed by humanity. At its heart lies a donut-shaped vacuum chamber weighing 23,000 tons. Surrounding it, the most powerful superconducting magnet system in history generates magnetic fields 200,000 times stronger than Earth's. Those fields keep the plasma floating in the center, never once touching the reactor walls. The magnets must be cooled to temperatures near absolute zero while, just centimeters away, the plasma burns hotter than anything else in the solar system. Extreme cold and infernal heat, separated by only a few centimeters of vacuum and magnetic force. Assembly tolerances are measured in millimeters on components weighing hundreds of tons. One tiny mistake and decades of work collapse. If this experiment succeeds, it will change civilization forever. Abundant energy with no long-lived radioactive waste. No risk of runaway meltdowns. No dependence on oil, gas, or coal. Humanity would finally gain access to the same power source that ignites the stars. And with it, a real chance to stop climate change before it becomes irreversible. Meanwhile, in Northern Europe, another project is rewriting the rules of continental connectivity. Between Scandinavia and the rest of Europe lies a natural barrier that, for centuries, forced travelers to rely on slow ferries or endless land detours. Building a traditional bridge was impossible. The waters are too deep. The storms too violent. And the traffic of massive cargo ships could not be interrupted. The chosen solution is extraordinary. It is not a tunnel drilled through rock. It is a tunnel built in sections on land, then submerged on the seafloor. 89 prefabricated concrete segments, each more than 200 meters long and weighing 73,000 tons. These giants are manufactured with industrial precision, towed out to sea, lowered with centimeter-level accuracy into trenches 40 meters below the surface, and sealed together to form a continuous 18-kilometer passage. Inside, 2 highways and 2 high-speed rail lines will allow crossings in minutes instead of hours. Rail travel time between 2 European capitals will drop from 5 hours to less than 3. Thousands of ferry trips each year will be replaced by a zero-emission electric corridor. This is not just infrastructure. It is the backbone of a new economic corridor permanently linking the north and the center of the continent. Engineering working with the environment instead of destroying it. And speaking of integration with nature, Asia is taking this concept to an entirely new level. Sea levels are rising. This is not an apocalyptic prediction. It is a measurable fact threatening dozens of coastal cities where hundreds of millions of people live. For centuries, humanity tried to hold back the ocean with walls and dikes. But how long can you fight against the force of a warming planet? The boldest answer doesn't come from defensive engineering, but from a radical shift in mindset. If you can't defeat the water, float on it. Along the coasts of East Asia, The world's first floating city is moving from blueprints into reality. Interconnected platforms that rise and fall with the tides, immune to flooding because they move with the water. The structure uses a revolutionary material that applies electrical currents to stimulate the growth of marine minerals over steel frameworks. The result is a material 3 times stronger than conventional concrete, and capable of self-repair over time. The city integrates closed-loop water systems, solar energy generated directly on its own facades, and hydroponic farms that guarantee food autonomy. It doesn't just minimize environmental impact. It actively regenerates the marine ecosystems beneath its foundations. Backed by the United Nations, this project is not a utopian experiment. It is a blueprint for the millions of climate refugees the world will face in the coming decades. The cities of the future may not be anchored to solid ground. They may learn to dance with the waves. And finally, in the desert, a tower is about to conquer a milestone humanity has chased since the first pyramids were built. 1 full kilometer in height. At those altitudes, everything becomes an enemy. The wind can generate deadly oscillations. The building's own weight threatens to crush its foundation. Conventional elevators simply cannot function because steel cables would snap under their own mass. The solution lies in an aerodynamic design that confuses the wind, foundations that plunge more than 120 meters into the ground, and elevators using ultralight carbon fiber cables that allow non-stop travel at breathtaking speeds. Every meter upward is a battle won against gravity. Every completed floor a world record. This tower is not architectural vanity. It is the catalyst for a new model of urban development. Growing upward instead of spreading outward. Preserving natural land. Concentrating millions of square meters of activity within a minimal footprint. It is a monument to humanity's ability to colonize the sky, and at the same time, a lesson in how the megacities of the future can evolve sustainably. 7 projects. 7 bets on a future many once thought impossible. Trains that fly without wings. Cities that think. Buildings that contain virtual worlds. Reactors that mimic stars. Tunnels beneath the sea. Towers that brush the edge of space. Cities that float on the ocean. These are not dreams from designers isolated in studios. They are projects under construction right now as you watch this video. The future is not coming. It is already here, taking shape in concrete, steel, and vision. Now it's your turn. Out of all these places, where would you like to live? Leave your answer in the comments. We want to hear your opinion. If this journey to the limits of engineering opened your mind, show it with a like. And if you want to keep exploring the impossible with us, subscribe and activate the bell so you don't miss anything. See you in the next video. Until then, keep looking toward the future.